Assalamu Alaikum, my name is Masriaz. You are watching my YouTube channel. We will solve a problem related to mass balance without chemical reaction having crystallizer operation, because crystallization is a unit operation and no chemical reaction happens in it. So let's start. In this video, we will also see that how you can convert the descriptive form of the problem statement into this pictorial view so that you can solve a mass balance problem easily. You can pause the video and you can see the statement of the problem on your screen. I will also write the problem in the description of the video so for your easy access. So let's start with the solution of the problem. So we are having aqueous solution of sodium carbonate. So as it is an aqueous solution, so it will be having sodium carbonate. In the problem I will denote sodium carbonate as Na. So it is 0. Its mass fraction is 0.1, remaining will be of water 0.85. You can denote mass fraction or weight fraction as W. No feed flow rate has been given to us, so you can take basis of 100 kgs as flow. After this, in the problem it says that on cooling to 278 Kelvin, water evaporates. So in crystallization, what happens? You cool the solution and crystals will become or form in the solution. So two phases have been formed after cooling. One will be the mother liquor and one will be the crystals. So now you have to cool or you can heat. In this problem it is stated you have to cool the this crystallizer and water will be evaporated. So for water I will write as C1 and the mass fraction will all be containing of water, because according to the problem no sodium carbonate is leaving with the water that is being evaporated. So here C2 will be for our mother liquor and C3 will be for our crystals that have been produced. So for the mass fractions of C2 we have been given in the problem the solubility of the solution. The solubility, it says that 9% weight of sodium carbonate is dissolved. So for weight fraction of Na will become 0.09 and remaining will be water 0.91. So now here comes the crystal, but in the previous solution or in the previous problem, the crystals that were being produced was only containing barium nitrate and no water was accompanied. But here in this problem it says that sodium carbonate is produced and 10 molecules of water is accompanying with this sodium carbonate. So here the mass fractions will not be equal to 1. The mass fraction will be for sodium carbonate and mass fraction will be for water will also be present. So how you can find the mass fraction of sodium carbonate and mass fraction of water in this crystal? So let's see. So now for finding the weight fraction or mass fraction of sodium carbonate, its molecular weight is 106. And for the complete crystal, the molecular weight will be 106 plus 10 multiply 18. So it will become 106 divided by 286. If you solve it, so it will become 0.37. Let me see what is the exact value. It is 0.3706. So here the mass fraction of sodium carbonate will be 0.3706 and the remaining will be water 0.6294. So in this way you have found out the mass fractions of sodium carbonate and mass fraction of water in the crystal. So I will raise it. After this you can see that we have written all the unknowns, but we have left one thing that says that 80% of sodium carbonate is being present here. So what is the amount of 80% of the sodium carbonate? So the sodium carbonate present is 0.1 multiplied by 100. So its flow is 15 and its 80% is present here in C3. So if we multiply it by 0.80, so it becomes 12 kgs. So here it says that 12 kgs of sodium carbonate is present in this 12 kg of sodium carbonate is present in C3. So what will be the amount of this C3? Because C3 is also having water present in it. So for the calculation of any mass flow, you simply do what we do. We do that weight fraction of that in that stream. So here you have been given that total sodium carbonate that is present is 12 kg and its weight fraction has been given to us 0.3706 multiply C3. So 12 divided by 0.3706 C3. So now if you solve it, you can find the amount of C3, that is 32.28 kgs. So C3 is 32.28 kgs. So in this way we have found another unknown value that was present. So now you cannot find any other thing by the problem statement. You have, for finding the other unknowns, you have to go to the mass balance. So the first step of the mass balance is to find degree of freedom. So the degree of freedom, number of unknowns remaining is only this and this. So the number of unknowns are 2. The number of independent equations are 2. As our all the streams are having only 2 components, sodium carbonate and water. So 2 minus 2 is equal to 0. Moving to the general mass balance equation, it is accumulation input minus output plus generation minus consumption. So accumulation, as it is a steady state process, no chemical reaction, input and output will remain and all the other things will be equal to 0. So our general mass balance equation will be reduced to input minus output. So now you cannot apply the overall mass balance because 2 things are unknown here. You will have to start by the application of component mole balance. So let's start. First of all, we will apply the component mass balance for sodium carbonate. So sodium carbonate, weight fraction of sodium carbonate, multiply its in its feed stream. It is the only stream that is entering, all the other streams are leaving, so they will be written on the other side of the equation. So here no sodium carbonate is present, so I will write as 0. Here it is 0.09 multiply C2, and here you can write as 0.3706 multiply 32.28. So now you can see that I had not written this equation in this form, so sorry for that. I will write as 0.15 multiply by 100, or I will write this equation as generalized form. So it will be 0 and weight fraction of Na multiply C2 plus weight fraction of Na multiply C3. So now it is 0.15 multiplied by 100. Here it will be 0.09 multiplied by C2 plus 0.3706 multiplied 32.28. So now you can see that only one variable, one unknown is present, that is C2. So you can find the value of C2, and the value of C2 is 33.33 kgs. After this, I can write as 33.33 kgs. So now you can write the balance for H2O, and you can find the amount of C3 by this equation as well. But as I had now know 3 out of 4 unknowns, so I can apply the overall mass balance for finding the C1. So 100 is equal to C1 I don't know, 33.33 plus 32.28. So 100 minus 33.33 minus 32.28 is equal to C1. So the answer will be 30. C1 is equal to 34.29 kg. So here the water that is evaporated is 34.29 kgs. So in this way we have solved this problem. I hope you like the video. Inshallah we will meet you in another video. Assalamu alaikum.